तो देखो प्रोडक्ट रख दिया और फायर इट आउट। थैंक यू वेरी मच। नहीं डेकोरेटिव पर्पस। All brown is phenolic, pyrethroid. Next time आओ आप yes. Yes.
Yeah. Good afternoon again. Good afternoon. लंच के बाद का एक आवाज आना चाहिए गुड आफ्टरनून का, जाग रहा है मालूम होना चाहिए. So good afternoon again. जाग रहे हैं? ठीक है. So अच्छा सीरा ज्यादा खा लिया किसी ने? ठीक है, सत्यनारायण का नाम लीजिए तो अपने आप पच जाएगा. Okay. So continuing our second session of third session of today, I am inviting Dr. Anand Gaurav, ITM SLS Baroda University. He is going to talk on data-driven machine and deep learning it's that only, no? Yeah. Method to predict hygrothermal degradation in FRP and methodology to selecting suitable predictor. Now, to introduce Dr. Anand Gaurav, he's an assistant professor with ITM School of the Liberal Studies SLS Baroda University, Gujarat. He holds a PhD and MTech. Dr. Gaurav has contributed to academic conferences, including serving as a session chairman at SII MCES 2025 conference, highlighting his active involvement in scholarly activities. His background and research interests align with the interdisciplinary focus of ITM SLS Baroda University, which offers program in engineering, business, computer science, design, pharmacy, science, paramedical, physiotherapy, nursing, and mass communication. I welcome Dr. Anand Gaurav to give a presentation. I would request that please be precise and cut off the maximum time what you can do with maximum input to the audience. Thank you, sir.
So, good afternoon, everyone. And my sincere apologies that my session was scheduled to be in the morning, but I could not make it. So, once again, thank you, Sesa. Thank you, since 2025 and Ahmedabad University for hosting me here to give a small talk on how machine learning and AI ML is going to change, or whether it has the capability to change how we test our material, we try to find out the properties of the material. So basically, it's not about whether the AI ML will be able to predict the residual strength of the material, but I'm here to talk about what kind of suitable predictor we should be using when we are trying to align or we are trying to implement AI ML in the property prediction of FRP composite material. So all of us sitting here, we clearly know that FRP material, FRPs are the brilliant material, but like everything comes to an end, these materials are also susceptible to environmental condition, provided they are very exposed for a very long period of time. But the issue is, it takes a lot of time, means a minimum of 100 hours of testing. So, and for a testing which can go up to like 3 years or 4 years, when you try to find out what will be the residual strength of a material or a particular FRP component, if and whether they are going to, if it is going to be extended or exposed to the environmental condition for a very long period of time. So I actually, when this offer was made to me, I was working in ITM University, but now I have switched to NAMTech, which is currently running in the campus of IIT Gandhinagar. Okay. So AI ML is a large field, very vast field, but as we know, all of these models cannot be used for our application in composite science and technology. There is very limited number of models which can be used for our property prediction, or whether the model can be used to tell us whether the component is going to survive, how long or how much time it will take for a certain amount of property to be degraded to a certain level, right? So there is a difference between how an AI ML code is made and what is the difference between our general programming. So no, not going, sir. Ah. So sorry. So this is how actually what is the difference between our regular and machine learning algorithm. For a regular algorithm, if you try to write a computer program to predict the mechanical property of a material after a certain period of time, we require to write the steps involved in predicting that property. But on the contrary, a machine learning program extracts the relationship between different properties using the data itself. So this is what this image is trying to explain. So machine learning program or coding has this inherent ability to extract the reason or relationship between different properties. So why machine learning, or whether we can apply this machine learning for property prediction or not. So machine learning is all about writing a code in such a way that the computer becomes smart enough to tell you how much property of FRP composite is remaining with it after a certain amount of time has been spent during its service life. So, but the problem with applying a machine learning model in our FRP composite is grave. First of all, the FRP properties vary from people to people. Same amount of materials, same manufacturing property, manufacturing process. If two different person are going to make a certain component, definitely the properties of that material is going to vary. So it is a challenge. Plus, why machine learning? It's a computer-based reliable method. Means if you are implementing a computer, the biasness is not there. Means you will not be able to manipulate the result which is coming out of the computer, right? Offers great flexibility. All you need to do is to change the label of the information, and the machine learning model will help you get that to the property. So it can basically help us cut down the cost which we spend in testing of material, and all it requires is the data which is available in the literature for industries, which is the data available with them, and they can use it to predict the final property of a material. But what is the problem? The challenges is the machine learning model requires a very large amount of data. The work that I'm going to show you is based on 2000 or 2900 data points. But if you have the data points more than like 10,000 or 1 lakh data point, the machine learning model is works superb. And that is the only limitation with machine learning model. So it's quite important that person or people from different domain come together, share their experimental data to make or create a machine learning model which is robust enough to satisfy your requirements. Heterogeneous sources means the data that I have used is from different sources, different articles. So obviously there will be non-homogeneity in the data. Domain shift between lab and factory. Some data was taken from the factory data, some data were taken from the laboratory conditions, and that is why. But machine learning model again has the ability to help you normalize all those data in terms of computer programming. So class imbalance and defects, because most of the literature that you are going to study, they are not going to give you the details of what is the void fraction of the composite, what was the route that you used for the manufacturing of the composite, what was the curing temperature, what was the ambient temperature, like this. But as a domain expert, as the person who is working in the field of composite material, it is important to understand, because you understand what are the important features that control the output of a given component. So just I'm showing you this kind of data right now on the screen. We can see there's no label in the data, but those sitting, I also know that we can see a general trend in the data. As the numbers on the left is increasing, the numbers on the right column is decreasing. So this data is unlabeled. It can be anything. It can be Taylor's tool life diagram, data from Taylor's tool life, or it can be a fatigue life diagram. But remember one thing, machine learning is never used for this kind of simple task. The task has to be means there should be large number of inputs so that a human brain fails to correlate between the relationship between them. And this is why machine learning model comes handy into it. So if I'm going to increase the number of columns, some of you will start getting out what is the relationship between these two columns. And then again, I further increase the number of columns. And eventually I put so much of data that me as a human, you as a human will fail to understand what is the relationship between these two data. But remember, machine learning model understand these data and help you generate a model which will give you the required answer. So what in the backdrop, what machine learning does, it makes a number of iteration, maybe millions and billions of iteration based on the number of data that you have given, and it will come up with a solution. And we don't need to know about how many iteration computer has. They make it in the backdrop of the calculation, and all we need is to make sure that the answer it is giving to us is correct to the best of our knowledge, because we compare the results from emanating from the ML model with the knowledge that we possess. And once we find out that the result which is given by these model is correct, then we can successfully imply those model in our machine learning model. So when we try to, or when we attempt to predict the residual mechanical property, it can be anything. It can be strength, it can be stiffness, it can be strain. And this talk is all about understanding what kind of suitable predictor means, whether we can target to estimate the residual strength or residual strain or the residual stiffness when it comes to implying the machine learning model in the. So these are the 6 steps that we generally go through when it comes to machine learning model. Problem definition, what kind of data do we have, what kind of evaluation criteria we are trying to put, what are the features of the data, and what model should we use. But what I have done in this work is I literally applied every machine learning model which is available there. So like 10, 11 models I have tested, and their grid search version means modified version was also tested. So problem definition is for us, since these are based on numbers. So regression, which is supervised kind of learning, was there. So supervised learning and regression was the problem that we are trying to cover here. So data and features. So when we deal with data, data can have 2 terms. One, like I showed you in the table, it can be purely numerical, which we call as numerical feature. But there, like if suppose we are using CFR and GFRP, these are called as categorical features. So computers are not very good in interpreting these names, but they are very good in interpreting numbers. So what we do here, we use one hot encoder, and what it does, it converts those categorical features into the numerical feature deemed fit for the machine learning model. So, so that kind of Excel sheet that I showed you is in terms of machine learning model, it is called as structured data. And if you are using some images or some acoustic signal, those are unstructured data. So my talk of today is based on structured data. So I'll be keeping it short on machine learning model, right? So this decides what kind of model we are going to imply, whether we are going to imply deep learning or we are going to imply machine learning. So since the data that I have gathered over the period of time was based in tables or Excel sheet, so machine learning was the model that we used. So as I told you, there are 2 different categories. One is numerical, one is categorical. Categorical does not contain number. And if you put these names in the machine learning programming, the computer is going to discard it. All it requires are numbers. So one hot encoder is given as an input so that these names can be converted into suitable numbers. So this is the number of features. On the left, 14. I have used 14 different features to predict the residual strength. So here we can focus that what was the saturation moisture content, 0.99%. Test duration was, it was minimum 336 hours was the duration. The maximum was 21,900 hours of testing. So all these factors contributed to the extent of degradation that the composite material witnessed when they are exposed for a certain period of time. So R square, MAE or mean absolute error, median absolute error, and root mean square error is the general statistical terms that we use to quantify the result or outcome of our machine learning model. So one thing we have to make sure that at least the data we are using in a machine learning model, it should be present in at least 10%, more than 10% of the rows of the data. Unless that is not happening, the machine learning model will not be able to trap the relationship between those important input features. So modeling, once we have decided what kind of data do we have, what kind of work we want our machine learning model to proceed with, then comes the selection of model. So selection of model, problem 1, it can be a structured data, so machine learning model, or if you have images, sound, some thermographic images, or some resin flowing images that you want to implement to learn about how the quality of the composite is going to get, we can go for deep learning model. So unlike conventional computer program, we do not need to write ML model from the scratch. To our luck, most of these models are easily available in the public domain, and what you can do is download it from the internet and start working in the model itself. So choosing and training a model, first the three steps are training, validation and testing, and then comparing the model whether one model worked good or not. But remember one thing, no one model is perfect. Your step is to imply, use all the model, test all the model, and then coming up with a solution is working great for this particular kind of data. So coming to the results section, this is splitting up your data in validation, training, validation, and testing. But I would like to draw the attention to the results part. Right? So coming to the result part, this is how the scattering of, this is how the machine learning model presents itself the data. Once you put the data, it tries to scatter, develop a scatter. It can be a bar graph also. How the target feature is varying when it comes to different input parameters. So this is for, this is for strain data, strength. The next one, these two are for residual strain and residual modulus. Means I tried to find out of these three predictors, which one is going to be the most suitable, so that we get not the accurate answer, but answer which satisfies our condition, our requirement. This is called as a Pearson graph, and it based on the data itself. This is basically not how a machine learning program or computer is seeing at the data. This is actually, I want to see what a computer is trying to see. That is why we generally make this kind of graph. And it relates between the different input parameters. Here we can see the yellow lines. The residual strength MP as 0.92, it clearly understood that it is related with the strength. Higher the strength, the higher the probability of the residual strength. And this is how machine, I did not write any kind of program to make them understand. The machine learning program understood this with the data itself, right? So talking about the results, here I have highlighted few results which is important to our nature. Fit of the data. TT is the decision tree model which had the fit of 0.96, which is the highest among all the tested model that we have done. And again, there is a model which is called as SVR, support vector regression. It has a negative fit, means it discarded the relationship between the data. And that is where the hyper tuning comes into picture. Once the SVR model was hyper tuned using grid search and cross validation, you can see that the fit moved to 0.88. Tremendous improvement from the previous result, right? Again, the same thing for the strain, and you can clearly see none of the fit in the data reached to a scale of our residual strength. So we can understand from this result itself that strain is not a very suitable predictor when we try to implement a machine learning model in the prediction of property. We should go for strength, or let us see what is the result associated with the stiffness. So here is the result associated with the stiffness 0.9805, 0.9842, 0.9769, pretty high compared to our stiffness, strength, residual strength and residual strain data. So this gives us a brief idea that if we are trying to implement a machine learning model to predict the residual properties after a certain period of time, we should not go for the strain property at least. Go for strength property or go for stiffness property, and then you will have the answer which will be suitable to your problem. Okay, so this is the grid search CV, means what is the cross validation score. So generally we try to have this score very high. Means this table shows you how generalizable was the result coming from different machine learning model. Higher the numbers, better the model. Means generalizability means how well my model is going to work when some unseen data is fed into the system. Because we are trying to predict something and you will be preparing your own input data. So if sudden new data is given to it, whether it will be able to generalize that kind of learning what it has attained over the training module. So it can be associated. So this result is associated, can be associated. So once hyper tuning is applied, different models try to hypertune its input, how it train itself in a different, and actually I'll share all these slides with Singh sir so that, and I have the manuscript also, which you can go through and you will find out that each model treats different input parameter differently. And they have a number of hyperparameters which needs to be tuned in order to get to the right result. These are the results from the best model. Each model which is having the best output, which is giving us the best output, right? And these are the heat map of input feature was kept at the priority. So we can see in the stress feature, particularly all model did not converge on a single module that strength should be the main priority. But when it comes to stiffness result emanating out of for the stiffness, we can clearly see almost every model supported each other that the residual stiffness should be the prime input feature, which should be there in order to predict the residual stiffness of the material. So these are the graphs associated with the prediction model. So blue dots here shows you the SVR, support vector regression. When a model, machine learning model discards the data, what it is going to do is going to predict some random numbers which is not associated or aligned with the input data given to the particular task. So every model is there, but it takes a lot of time. No one model is perfect. Remember one thing, if you are trying to implement machine learning, you need to keep this in mind. No machine learning model is final. No machine learning model is great. It may require, it may vary depending upon data to data, and a great amount of experimentation is required so that you can narrow down on the machine learning model which can help you get the required answer. So conclusion that I can draw, that not all the models, I told you, not all the models are capable of supplying you with the answer which is deemed fit, but at the same time trial and error is the only thing go for when it comes to finding out the result. There are like 10, 12. If you include deep learning, there is like 15, 20 different kinds of model. So as a machine learning enthusiast, as a machine learning engineer, it's your responsibility to test all the data, test all the models before you finalize or narrow down on that this kind of data is final to my work. Or suppose you can start outsourcing that software to different composite manufacturing industry so they can have the brief idea that what kind of end property they are going to get when it comes to fabrication, when it comes to property degradation over the period of time. And that can be a great project for people working in the field of masters or doing masters from this Ahmedabad University. This can be a final year project for you guys, working on a data, developing a machine learning model, and then selling it to the industries so that they can come up with a final answer. So if based on my result, I'm just going, this is the last. If generalization means ability of a model to make a prediction even on the unseen data is the case, then BRR or ridge regression, Bayesian ridge regression, ARAB is it is a regression model. Then GBR is gradient boost regressor. They can be your model of choice. But when changes, the requirement changes from generalizability to fit, then our decision tree, support vector regression, and GBR or gradient boost regression is the model that you should go for, provided you are fixing residual stiffness as the suitable predictor. So we are, as I told you, NAMTech is a new university. It is running in the campus of IIT Gandhinagar right now. So these are my details. If someone is interested, we can have further talk or about the future of this work in terms of composite industries as well. Thank you. Thank you for that.
Please. Thank you, Dr. Anand. So correcting that you are now part of NAMTech. I would request Mr. Ulkesh Desai, please, to felicitate him with a token of gratitude. Thank you, Ulkesh. Thank you. Thank you very much. The next, I would request a presentation from June Private Limited. I would request a representative from June to please. I welcome Mr. Prasanna Venkatesh to give the presentation, and I would request him to make it as fast as possible
Certainly,
so that we can accommodate other.
Thank you, sir. And very good afternoon, ladies and gentlemen. I am here now to present our digital cutting solutions from Zund System Technique. Yeah. Yeah, but before actually getting there, let me just give you a quick introduction about the company per se. So Zund, we are a Swiss company based out of northeastern part of Switzerland. Alstaten is the name of the place. The company itself was established way back in 1984. We are a little over 40 years now in existence, through and through into manufacturing of digital cutting solutions for various industry segments. Composite is one of them. Apart from the facility what we have in Switzerland, we also have subsidiaries globally. These subsidiaries actually are, give proximity to us for the markets where we serve. One of such company is Zund India, and we are located here in Bangalore. We have a full-fledged customer experience center here with a couple of machines for us, for our customers to come and experience as to how we can offer them solution and how we can add value to their business. In Switzerland, we are about 260 odd employees, but globally, if you see, we are little over 520 employees, producing about 1,000 machine and odd. A little insight into our operations globally. So we are 14 companies outside of Switzerland with additional 60 sales partners. We all have about a little over 300 trained and certified technicians to handle our after-sales processes. So in addition to the cutting solution, the digital cutting machine itself, we also offer relevant software services, which goes hand in hand with our hardware services. We also have our in-house spare parts and consumable, support partners in Switzerland. And in addition to these, we also offer you pre-sales and post-sale services. Over 15,000 customers globally, spread across 100 countries and over 25,000 installations in various different industry segments. Sustainability is the core of Zund. It even translates into our machinery. We talk about the machine's life of about, let's say, 15 to 20 years at least. So coming back to the composite market itself, what kind of a solution is that we offer to the composite market? Yeah, so composite market per se, if you see, is diverse in its existence. I would say it's not only focused to one particular segment. We have transportation. The use of composites is not limited to that. We have industrial, components being made. It's used in sports and leisure. Defense and protection also for making bulletproof jackets and things like that. Wind energy is a big segment again. Architecture is catching up. Not so much so in India, but I heard that from the earlier presentations that it is slowly creeping in. Science and education, obviously, So what are the substrates that we actually can apply our solutions to? It's not only limited to the composite, I would say carbon or glass fiber fabrics, but also prepregs, unidirectional tapes, core materials which are used in aerospace and defense, even cured component of GFRP and CFRP, auxiliary materials for sure, thermoplastics, hard foams, and also sandwich materials. We also have various workflows for handling the substrates, right from carbon, glass, and aramid fabrics. We can cut and mark the prepregs as well, cutting and routing thermoplastics, cutting and routing core materials, routing of fiber reinforced plastics, and we can offer a fully automated cutting and sorting kitting solutions to the industry. Let me just quickly show you a small video so that you'll get more insights into this. So that's the screen on the machine itself. The cut components are sourced from your AutoCAD or CATIA in the form of vector files, could be DXF, could be PDF. We have an elaborate library, the material library itself. So in order to save material, we have a full-fledged nesting program, which we can offer along with the machine. A little bit of addition also is possible on the machine itself. Zoom Cut Setter is actually the core software what we use in the machine. That's a tool. It's a drag knife which is being used to cut prepregs. So here in this video, you can actually see various different principles we use to cut different materials. So what you're seeing right now is a prepreg material. What you saw earlier was an inkjet printer. Now this is cutting. We also can offer felt pen to mark, something like this. This is also possible. This is a label applicator for kitting and sorting purpose. Comes in very handy. You can actually print your data into this and then apply on the prepregs so that it is very easy for the operator to actually sort it after the cutting is done. You can also print a barcode or a QR code for identification. So first what you saw was a prepreg. Now what you're seeing is a carbon dry fabric. Here we have used 3 layers of cutting. The principle is here a rotary knife, what we are seeing. That's a rotary knife again. This is glass fiber rather. Again, 3 layers we are able to cut. So we can cut maximum of 2500 GSM at one go. The entire substrates are held with the help of vacuum underneath the table. Aramid fabric. So all the dry fabrics are being cut with the help of rotary knives. Coming to the thermoplastics. Here what you're seeing is an ultrasonic tool. So this is able to cut precise shape. The same ultrasonic tool is being used to cut condensed layers of aramid fabric. It's about 30 layers here. This is a filler material generally used in aerospace and defense. So here we cannot use a rotary knife since it is thick. So we are using an oscillating tool here where the knives keep oscillating while cutting. This is a pneumatic oscillating tool to cut honeycomb materials. Another application. So this is a pneumatic oscillating tool which is cutting. And we are going to use also a router to give you some shape of this kind. So this is also possible with our machine. Roha cell being cut by a router. So this is a router which uses a drill bit. You can see no dust coming out because everything is sucked with the help of a vacuum. We can also cut cured component like this up to a thickness of, let's say, 8 millimeters. So all what you saw was on the same machine. The machine has not been changed. Just by changing the tools, we are able to offer you digital cutting solutions. Cutting and sorting and kitting as well. We can offer you the complete solution for your cutting needs. This is a very important feature of our machine. All the electronics and electrical components are coated with carbon protection, which is essential because we are talking about carbon here, which is a highly conductive material. All the substrates being cut on the same machine. We can also chamfer the honeycomb structure. Very safe machine. The moment you put your hand, the machine stops. And you'll have to release a light barrier error to resume from where you stopped. Very robust. All the parts are made available through web shop. Few of the certification, safety certifications, what we have from the market. We are also an ISO 9001, 14001 company. Care about environment. Few of our global customers. Oops. Okay. So a few of our customers in India. I am sure you're familiar with most of the names already. Here you can see our global clientele. You can see the choice list of names here. Most of them are using multiple Zoom machines, and most of the products are manufactured on Zoom itself. Yep. That was a short presentation from Zund. We are here just outside this. If you have any questions, any clarifications to be made, I'm here today and tomorrow as well. So if you have any questions, please visit us. Thank you once again for the opportunity. Thank you.
Thank you, Prasanna, for a very information and strict presentation showing how cutting would be helping composite industry. Exercise cutting will be helpful to the industry as well. I would request Vasant Uchil Sarji to please felicitate. Prasanna, yes, sir. Thank you.
All right. Thank you very much, sir. Thank you.
Thank you.
Thank you. Thank you.
So for the next, basically, I welcome Sri Vasant Uchil, a phenolic resin-based expert from Mumbai. He is a legend in the composite industry. Resin is his language, I would say. You can say we are mother tongue is our language, but his mother tongue is resins, phenolic resins. He has authored articles on the topics such as room temperature, pure phenolic, GRB, showcasing his expertise in the field. His contributions are valuable to professionals and researchers interested in phenolic resin application. So I welcome Uchilji to give a presentation on surface finish coating of fiber composite panels and products. Welcome, sir.
Thank you. Good afternoon. I will take you around a wonderland of composite applications. The topic I have taken today for either आवाज ज्यादा है
नहीं आपका आवाज सही है.
अच्छा Yeah. Okay. I'll give my little background. I think I'm the second oldest veteran in this field in India after Dr. Sharma, who was there yesterday. My background is I'm an engineer working with Bakelite Hylam for resins, then Deca fiber for glass fiber, and then TIPCO for finished products, and Bakelite Germany for training. Widely traveled, except America. The topic I have taken today is the surface finishing, coating, and painting of composite products. Why I have taken this topic is, if you see in India, finished product in composites is not of a good sellable product like. So what you have is, one is surface finishing is by hand lab or your automation, RTM, or even compression molding. Then that is around 80% of the products made in India needs a surface finishing. And coating is post manufacture. Coating could be a resin, a metal, gold, silver on composites. And painting is, to be very frank, to hide the defects. Painting is being used in our industry. Yeah, surface finishing is critical to the long-term appearance of composite products. Coating is also for aesthetics, durability, and painting is primarily for decoration and enhance resistance. These are all post-operation. This is in operation. There is a misnomer in this industry. We call FRP as fiber reinforced plastics, which is a wrong word. Plastics is a wrong word to use for FRP. It is fiber reinforced polymers. When you say plastics, general Aam Janta, if you take an auto in Ahmedabad and if you see the mudguard of a auto, it is cracked. And if you ask the driver what has happened, he will say, oh, fiber is up. Fiber is a misnomer. We are into fiber reinforced polymers and it has to have a good finish of is the need actually, and quality surface finish is not optional. It is compulsory to have a quality surface finish of the product if you want to be in the market for long term. I'll take you to some applications of land surface movement, trains, automobiles, aerospace. See all these trains, if you see this train, the finish is excellent. If you see in Shanghai, your bullet train, no, it is other train, that is also good finish. This is our metro, this is our inside metro. See, all these products are made of fiberglass composites, whether it is external, internal, and in many cases, it is fire retardant product, which is not visible from outside. And I am mastering fiberglass in phenolics, which is a inherent fire retardant product. So these are the products. So marine applications. In our industry, we say class A finish. Class A finish means it is like a mirror. If you look at this boat and if a man with a good hair, he can comb his hair. That is what is called as class A finish. This is class A finish. See, that is a class A finish, but it is matte finish. The importance of finish here, when boat is gliding through water, it has to have no resistance. It has to go. So the finishing is very important in this application. Now, naval, I'm doing some work with defense authorities, submarine, frigates, and this also stealth vehicles, I mean naval vehicles. These also have got different, it should not be class A finish, but it has to have a good abrasion resistance, resistance to salt water. So these are all been made with special resins by hand lab or by automated systems. Now, this is a stealth naval craft. You see a lot of layers of glass fiber being used in this. Now, aeroplanes, if you see, it's a normal aeroplane. That is the inside part of an aeroplane. The engine, the blades, and the cowl are made in FRP now, and that is a glider, which is not painted. It is gel coated and with the color. You may think it is a painted one. It is not. It is gel coated one. नहीं जा रहा. Now, composite parts in aircraft, if you see, around 45% of products in an aeroplane today is composites. It could be glass fiber, basalt fiber, carbon fiber, even some natural fibers are being exploited now. Now, helicopter, this is a recent development and there's a big scope in India for industrialists to get into this business. This is a normal helicopter used by industrialists in India. This is army, that is high altitude helicopter. Now drones is everywhere. This is going to be at least 30% of the aerospace application in India in future. So anyone a student interested in developing a new product, this is the business you have to be in. Because the old people will not venture into this. You people with young thoughts and computer conversant can do these jobs. Yeah, something. See, this is made by Sony. This is a solar panel based vehicle. This has won a award also around 10 years back in a open competition. All these solar panels are backed by composites. It's carbon fiber, it's basalt also for heat resistance, that's glass fiber, there is aramid, there is Kevlar. It's a combination of 5 fibers being used in this application. Now coming into automobiles. See, this is class A finish, the red one, what you see. The yellow one is a racing vehicle. BMW also has slowly converting into carbon fiber bodies. The i3 electric vehicle, I think somebody showed that slide now, that is totally carbon fiber. Now, foam insulated FRP van, this is for refrigerated vehicles. This is got a sandwich of polyurethane foam or phenolic foam, depending on the application. And this is also a good product to get into. Now, motorcycle parts, there are many. That's a normal helmet. This is a military helmet. This is made of basalt, the down one. Now, anti-ballistic field tank. This is something new. I'm involved with the Indian Army on this project. And this is a sandwich of glass fiber, carbon fiber, basalt fiber, Kevlar, aramid with epoxy for the moment. And I'm slowly converting into phenolic to make it fire retardant. If you see a Hummer vehicle, I think Sunil Shetty owns a Hummer vehicle, that body is also made of the same material. Yeah, this is another anti-ballistic field tank. This is made completely of basalt with phenolic. So this will come in Indian Army maybe in a couple of years. Yeah, this is a anti-ballistic application where I told you there is a sandwich of 5 materials. It also includes a ceramic plate. It also includes aluminum honeycomb in this. So this is the point of contact. And there if you see on this the back side of the plate, you see only one impression at the center. Otherwise, the bullet is stuck inside. Now coming to industrial applications. Now this is a normal grating. I have a grating here. This is a phenolic grating. But if you see, it has got a rough surface so that in ONGC, oil industry, it should not slip. Otherwise, it will go into the sea. So it is normally sand is used, or a sophisticated material is also used, which is available with me, and it is heat resistant also. Phenolic is fire retardant. The top coating is heat resistant. Now these are different kind of carbon fiber laminates. Not working. I think I expanded too much. This is a fiberglass Walmart office cabin. And this is of class A finish. If you see really in any of the malls, you will see this is a gel coated cabin. Yeah, this is my expertise. This is a house with a cladding of phenolics. It is fire retardant panel, completely fire retardant structure. If you see, let's say joint, because we cannot make such a big piece in one mold, so it has been joined again by phenolics only. There's phenolic adhesive, not epoxy adhesive or polyurethane, phenolic adhesive. This is in Malaysia. Yeah, this is a football ground stadium where cladding is used in a different shape. Aisa. Yeah, now coming to the decorative purpose. This business is around 20% of FRP composites, decorative. See, this is stained glass you have seen in Vichy Station or Baroda palaces and something. I have converted this into crinkled glass with transparent resin. The resin is used, this is the resin. 100% transparent. This is how we use this. This will come in the market soon. And these are, in Japan, if you see, the bathrooms are not built like what we build in India, like a cement structure, then tiles, call a plumber and all. Here it is a panel of glass fiber, three-dimensional or single phase, and it is laid in such a way, and cement is poured from outside, inside, that side. So what you see is the bathroom wall. Behind you pour the cement. It is not unlike we put the tiles. This is totally panel. It is ready made, and one bathroom can be made in half a day. It will come in a truck. They will make a bathroom and then go away. You pour the cement whenever you want. Now, this is a fantastic product. I am coming to coating. You must have seen Ashta Lakshmi. There is a different Lakshmis, Anna Lakshmi, then Dhanya Lakshmi, that kind of way. This is Santana Lakshmi. If you see, this frame is made of fiberglass, the total, and it is coated by real silver. This is something new for the industry, and this is being sold for 1,10,000 rupees. And one jeweler from Zaveri Bazaar have purchased all the 8 in an exhibition by paying 10 lakh cash on this. This is very, very beautiful if you see. The intricate wood carving, then from pattern you make a silicon mold, from the mold you make a product in FRP, and then you coat it in with silver. This is another mirror frame. This is coated with dull faced gold, real gold, but dull finish. Yeah, now I'm coming to painted. Many products cannot be done in gel coat finish. The artists have different mind, interior decorators have different angle to how the product should look. This is a painted planter. But it's a FRP planter. It's a huge one. If you go to any 5-star hotel in Bombay or Delhi, this kind of products which are made in FRP. This is around 6 mm thick. So I'm going to the process. This is vacuum infusion by silicon rubber. That is again VA RTM, vacuum assisted RTM, where you can get double finish also if you want. This is a helicopter, what should I say, rotor blade. See, this is a very unique product. It not only has to take a load vertical, it has to take the twist also. The shape of this is called aileron. It is very, very difficult to make. To make a mold has taken around 1 month for this. Now, we also have honeycomb core panels to make it more lightweight. Like helicopter body is made out of honeycomb panels with FRP or carbon fiber. Whatever. Yeah. I have a good video, but I have signed a NDA with the defense authorities. All of you must have seen James Bond movie where Sean Connery drives a car and it falls into a river and it goes through the river also. So now the latest product which is used for spying is the car has to move on the road. It has to go as a boat in the water and it has to go underwater like a submarine. That is a spy vehicle which I have been involved in developing this. This could go for Indian Army maybe in the 5 years maybe. Why I'm showing this slide is the flow chart, the SOP, standard operating procedure for making any good product is having a good, what should I say, pattern or plug, what you call. Then you make a good mold out of that. And from the mold, you make a good product. Unfortunately, in India, all the manufacturers try to take a shortcut. Shortcut is not allowed. I am a 100% quality man. SOP means SOP. You have to follow this. So, how to make a good pattern? It can be made of wood or it can be cut from the foam. And then it is finished in such a way that when we take out a mold, it has to be a mirror. The mold has to have a mirror finish. So, we have a release agent, which I have developed through a German company. So it will come in the market soon. And the mold can be of silicon rubber or it could be as it is. A new mold, you have to wax it 6 times and you have to apply release agent 7 times. Then only you get a good finish. And a mold has to be of a dark color, either red or black, so that it can reflect by looking at the mold, you can say how the product will come out. So this standard operating procedure is not followed by not a single molder in this country, which is very sad. Why is? And then you make a mold. The sealer, mold release wax, liquid release agent, tooling, gel coat, unwet gel coat first, gel coat spray gun or brush, surface mat, chalk strand mat, isopolyester resin or vinyl ester or epoxy also, MEKP catalyst shredder, fiberglass roller, plastic wedges. To remove a product from the mold, I have seen almost 90% of our molders use a screwdriver and try to tap it with a metal hammer. That is wrong. There are enough spreaders and plastic wedges available. Then the polishing agent and the buffing to get a class A finish. ये मेरे से चलता नहीं. Yeah, this slide shows what you must have to have a good mold. One is a good stirrer for the resin to mix. See the shape of this stirrer. The stirrer should not be a stirrer should not stir the resin only this way. With this, you can have a multiple movement of the resin and the catalyst together. And these are the small rollers for corners. And these are air removers, all this. This could be in LDP, PP, or even aluminum. And another mistake what we make is we add catalyst by measuring in a spoon. There are equipments available. You put catalyst inside that and then you just squeeze it. You will get whatever you want. These are the wedges to remove the. And last one is a lamb's wool roller, which 95% of the people in India do not use. They are using a normal brush. I am trained in Germany. I don't use brush. I use only rollers. In brush, you are putting air into the product. In roller, you are removing the air from the product. The air is there should be a damage control if you have air in this product. So this is how a good molding practice is being to be followed. I give free service to anyone in the industry. I don't charge. So if anyone wants me to train people, I train a lot of people to Middle East and Saudi and Singapore. So I'm a certifier. That if I certify this guy is a good guy, so you get a good job and get a fantastic salary. So anyone, even the university, if they want my services, I'm ready to come and teach how to make a good product. Thank you. बुक में आ गया, बुक में पढ़ने की जरूरत नहीं।
Thank you, Vasant ji, for your beautiful presentation and showcasing how